This morning we're going to talk about more preventing callbacks, but more on the technical practices side. And all this stuff is just super obvious. It's just stuff that we got to go back over. The things that are in this class are practical things that I actually do expect. And not that it doesn't matter what I expect. These are standards that have been laid down by the forefathers of our great trade. I don't know who they are, but they laid them down. They laid down some sick beats, and we're just marching to the beat of their drummer or something like that. I don't know. Brazing. The number one thing that I see newer techs or newer installers who are really bad at brazing do is they just don't apply enough heat. So they don't get in with enough heat, and so then it takes way too long. So if you imagine the two things that can cause damage to components are brazing too long or burning things that you didn't intend to burn, getting heat places that you didn't intend to get it. So that's both surfaces that may be behind the brazing area, wires, all that kind of thing, but then also heat that's conducted into valves. And so the way you protect that is, if you're near a surface, you use either a heat shield, like a piece of, you can take a piece of snap lock, metal duct, bent out, cut it, keep a piece about that big in your truck. It's just a nice thing to have. Or you can use one of those solder weld heat shields, or you can use the big, heat shield drop cloths that we have. But you need to have some sort of heat shielding, and that's to protect things that are behind the work area. Anybody here use air-acetylene, the turbo torch? Anybody? Man, I wish we would use that more, because I really think for newer folks who are learning to braze, I think it's the bee's knees, and that is a technical term. Literally, the knee of a bee. I don't know why that makes me laugh. Just imagining a bee with knees. Anyway, this is not going well so far. So air-acetylene is really nice to learn on, but the downside to air-acetylene is that it does have more of a convective flame, which means that it pushes heat out further. It's not actually as hot at the flame, but it produces more heat behind the flame. So if you do ever use a turbo torch, really nice and easy to use. It's got a nice big flame, so it heats a little bit more evenly. Point being that in order to braze it in, you want to get the fitting, the entire fitting, to dark cherry red, not bright red, because then you're about to make a hole in it, but just deep cherry red. You move your heat in and out and all around until you can get most of the fitting deep cherry red, and then you apply your solder, and you do that as quickly as possible. But then you also need to protect the heat sensitive components. You can use a wet rag, or a set of wet rags, or a wet toilet paper, or wet paper towel, or whatever you happen to have. Or you can use a product like WetRag or Hot Block from Solder Weld, or whatever else we have here in stock for that. Some people like the heat spray gel. The heat spray gel isn't really, a lot of people will just spray it on the fitting and think that's gonna keep it protected, and it's not. That stuff will disappear in no time. But if, for example, if you have a really tough to protect area that's a little bit away from the work area, you can spray that on it in order to kind of help protect another area that's around where you're working. Does that make sense? Have you all ever seen that? It's in the spray bottle. It's just like a clear gelatinous goo. I was looking for an opportunity to work that into a sentence today. Gelatinous goo. Leak detection. Bert's talked a lot about this, but you always follow this process. So, and I would probably change the order here a little bit. First, visually inspect your connection point. So before you even pressurize with nitrogen, take a mirror or use your cell phone, whatever, and look around the entire connection. Make sure that there aren't any visual gaps and cracks. Pressurize with nitrogen, and then use soap bubbles, which means that I don't care if you're doing an install, I don't care how confident you are in your work, put soap bubbles on all those joints and let it sit and look for that little microfoam that can build up, because pressure testing with, say, 200 psi of nitrogen, you may not see a pressure drop that's significant enough for you to believe it in that period of time that we typically do a pressure test. Now, the longer the pressure test, the better, but the worst thing that I see is guys they'll pressurize up to a certain point, and then they'll forget what they pressurized it to. And then they go back and it's dropped a couple PSI, and they're like, oh, I think that's probably normal. It's probably just equalizing out. I can't tell you how many times I've heard that. I can't tell you how many times I've said stupid stuff like that. So the point is that when you pressurize to a point with nitrogen, you need to know exactly what that is. And that's where you can use something like the delta P setting if you're using Testo 550s. If you're using wireless probes, a lot of them have that. mode where you can do a delta P, which means, delta means what? Anybody know when we say delta, what does that mean? It means change, right, or difference. So delta P means difference in pressure. So you set it into that pressurization mode and then you just see, is it dropping at all? And if it's dropping more than a tenth, that's an issue, right? So that's a big one, but then use those soap bubbles, overuse soap bubbles. Learn how to apply soap bubbles in a nice stream, so that way it's not creating foam to begin with, so it's nice and just kind of sits there. And then when you come back and you see that little bit of foam building up in an area, then that's an indication that you probably have a leak there. What I would do then is just apply it again, and then just kind of actually sit there and watch it and see if you can start to see that foam building. Does that sound right, Bert?
That's great.
Leak detection is like your thing.
That's right.
Yeah, okay. And then do a standing pressure test for 20 plus minutes. And again, I say 20 plus minutes because I'm being realistic here. This is a realistic process. Don't do less than 20 minutes. I would love to see you do longer. And so that's another reason why getting all your brazing done as quickly as possible is super helpful, because then you can have the longest possible nitrogen test that you can have. That's another reason why pulling vacuums fast is also handy, because it gives you more time that you can do your standing nitrogen. If you know your vacuum is going to take you 2 hours, then you tend to rush the pressure test. If you know it's going to take you 5 minutes, then you have a little bit more time in your pressure test. So pulling proper vacuums is a big part of that, which brings us to our next point. Pull the system below 300 microns if you can. And you'll notice I say if you can. On the type of equipment that we work on, you can. There should be no problem pulling below 300 microns in a hot minute. What's a New York minute? What's a term for a really fast amount of time? Come on, somebody. In a quick second. Bert got cats yesterday. So pull below 300 microns, and the way you pull below 300 microns is you remove your cores, you use large hoses. We generally, if you're doing an install, we use the one hose method. So pretty much everybody here use the one hose method at this point? Everybody? So you pull below 300 microns, but a really key thing is then you valve off at your core tool or tools, and the system shouldn't decay to 500 plus microns in 10 minutes. Now again, this is a new install. This is copper and an evaporator coil that's never had oil in it. When you start to work on a system, especially if you're pulling on the compressor, where it has oil in it, and that oil has refrigerant entrained in it, potentially some moisture entrained in it, you're often not going to get these sorts of decay numbers. You're often not going to be able to hit them, and that's okay. So knowing the system is a big part of this. But for what we do, residential changeouts, you should be able to hit that number easily. That's your indication. If you pull below 300, you valve off, and within 3 minutes, it's above 500, pull it down again, do it a couple more times. You may be just drying it out, but if not, then you probably have a leak. So at that point, you need to start over again, find your leak. Again, leaving leaks nowadays, bad, 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 bad. Among the worst callbacks we can have are leaving refrigerant leaks, because refrigerant's really expensive, and because leaks cause systems to freeze a lot in our market, which then causes damage to brand new equipment, brand new platforms. It's just a bad thing. So we do not want to leave leaks ever, ever, ever. We want to take every possible precaution, that's the word I was looking for, precaution, in order to make sure that we don't leave leaks. And so the vacuum, though we're not using the vacuum to leak test, we are using it as a final confirmation that we do not have leaks. Are there any questions about these two procedures? Because if there are, get answers to these two procedures, because they're very simple. I've done videos, in-depth videos on both of these. Bert did a video on leak detection, and then vacuum, we should be crystal clear on how we pull vacuums, because it just makes our life so much easier when you have that procedure right, because then it only takes like 5 to 10 minutes in general.
Why do you prefer the one hose method?
I prefer the one hose method because it's a simpler method. So when you only use one hose, there's less to go wrong. You have less seals, you have less core tools, there's just less that can go wrong, and we find that you still, again, on a change out, because your copper's clean, your evaporator's clean, you still are generally pulling to these levels in under 5 minutes. So there's just no reason. The other really valuable reason, and that I forgot when I first started speaking, was that now your micron gauge is on the far side of the system and it's not being affected by vacuum. So when you see a 300 micron vacuum on the liquid line, on the complete other side, you know that that whole system is pulled down. If you're putting your micron gauge near the pump or near where the pump is pulling, that micron gauge is being affected by that pump. And so as soon as you go to do the decay test, you get this big jump. When you do the one hose method, and you guys have all seen this, many times you valve off and the vacuum actually keeps dropping because it hasn't equalized out on the negative side all the way to the other side, which is kind of nice, right? You have that full confidence. If you're pulling on both sides, You just have to wait for it to equalize, and then you watch it decay, which just takes an additional skill, plus you add some additional variables. Now, if you are pulling on an existing system where you're doing a service repair, and you're pulling on copper that's had refrigerant in it, or a coil that's had refrigerant in it, or a compressor that's had refrigerant in it, then use the two-hose method, because you want every possible advantage you can get, because those vacuums are still much more difficult to pull. That makes sense. Big difference between a change-out vacuum on new copper and a new evap and a service vacuum on a part of the system that had refrigerant in it previously. Big difference. And your expectations should be different. That vacuum's just going to take longer. A service vacuum's just going to take longer. Make sense? Okay. Check the system infrastructure. So as part of your commissioning, make sure that you keep your drains 2 feet or more from the slab. Keep the units 2 feet or more from walls or shrubs. And make sure you know your line lengths and your charging requirements associated with line lengths. So you're doing a change out, you need to be thinking about what length is this line set. If it's an existing line set, you can still kind of figure it out. I mean, you may be plus or minus 5 or 10 feet, but you're going to be pretty close. And then you use the charging calculator on the HVAC School app. We just simplified it to make it a little easier in order to calculate how much additional refrigerant you have to add in. If you do have to add in any additional refrigerant, in many cases you don't. Make sense? Any questions about that? All these things will help you prevent callbacks. Ensure you have proper refrigerant charge. I am still a fan of non-invasive testing. I know that we're not always practicing that, and sometimes it has to do with the fact that we've got newer techs. Sometimes it's difficult to know when you should use non-invasive and when you shouldn't use non-invasive. But as an example, like I would much prefer when we're doing things like cleaning drains and changing capacitors. And when I say, I have to be clear here for a second. When I say what I would much prefer, that doesn't mean I want you to leave this room and do things other than exactly what Bert and Sam are telling you. I'm just telling you this is the way I would generally like us to operate once we have the skill to do so. I would like us to do non-invasive testing when we're doing those drains and capacitors, which means that we're not hooking up gauges. There's ways of testing the equipment with 99% accuracy using only temperatures without hooking up gauges. And we've talked a lot about this in the podcast. We've done videos about it, all this sort of thing. And it just comes down to really understanding what to expect. Now, that is not a lot of people will say like, oh, you're taking the skill out. No, actually not doing a proper non-invasive test is actually a more skilled test than hooking up gauges. Does that make sense to everybody? Do you understand what I'm saying? So I'm not saying when you set up a new piece of equipment that you don't have to check the charge with gauges and do subcool and superheat. Obviously, you put in a new component in the system, change an evaporator coil, change the compressor, change the blower motor, whatever. Then yes, go ahead and hook up, do the full retro commissioning, recommissioning. But when you're doing things like a basic repair or even potentially a maintenance, I definitely suggest doing non-invasive testing. And ductless systems are another example of that. When we do ductless maintenance, some customers want to see you hook up, but in general, just hooking up to the system is another possible thing that can go wrong. Know what your superheat and subcooling signify about your charge, and I've talked about this a lot. Superheat equals evaporator fill, and a lot of people say, no, it doesn't. It's a quantitative measurement, not a qualitative measurement. Look, what I'm saying is that on the same system, under the same conditions, if you have an evaporator coil that's more full, you're going to have lower superheat, and if you have an evaporator coil that's less full, you're going to have higher superheat. And the same thing is true with your condenser. Subcooling equals condenser stacking. How much refrigerant are you stacking in the condenser? Higher subcool means you're stacking more, lower subcool means you're stacking less. And that's what I want you to understand. Know that's what those numbers are telling you. They're not telling you anything about temperature directly of the evaporator coil or the condenser. They're just telling you how much refrigerant are you stacking in those. Does that make sense? Use a scale to weigh in the charge. If any of you are pulling out tanks, recovery tanks, or refrigerant tanks off of your truck without pulling a scale off of your truck, today should be the last day, or yesterday, should be the last day that you ever did that. Okay, so if it's like, man, I just haven't been in the habit of it. Okay, today you get in the habit of it. Well, I don't have a scale. Well, today get a scale. It will save you so much heartache. It will save us so much heartache using a scale. You won't overcharge systems. You'll charge the right amount for refrigerant. And I understand why people get lazy. Sometimes I use a scale, but sometimes it's just a little bit. I'll just add a little bit. No, we're done with the days of just adding a little bit and calling it a pound. That's not what we do anymore. Okay, just always, always, always use a scale. Did everybody get that? Everybody agree with that? And now whenever I say this, people on YouTube are like, well, of course you should have always been using a scale. Well, you can say should all day long, but I know there's a lot of techs out there who don't use a scale. and we just need to be using a scale. It's funny because Interplay has this whole thing about how to charge by subcooling, and it's a interactive 3D virtual reality experience. And I'm not dogging on Interplay, but okay, maybe I am a little bit. Not really. It's just, so, and it shows you, inverting the refrigerant tank and all this, and guess what's not there while they're charging? A scale, right? So it just proves that, the only time a lot of technicians are pulling out the scale is when they know the camera's there. Because they're just, oh, oops, oh, yeah, that's right, I'm supposed to be using a scale. We got to translate that into the world of we always just use a scale, because it's no longer one of these things that's an industry best practice that we all ignore. It's something that, as far as running good business, we just have to do. Refrigerant's costly, so we can't make mistakes with that. And check for leaks if you suspect a low charge. So don't just add a little bit of charge to it. In many cases, it's going to be best to go ahead and quote the leak detection before you even quote to add the refrigerant. And I know that's backwards on a lot of our practices. Again, if the system is flat, obviously, you can't do a leak detection. But if it's just a little low, it's best to get the where's it leaking question out of the way before you even start doing the adding refrigerant part of the equation. Because it gets you disciplined to not have that as a back end, oh, hey, you might want to do a leak detection, right? That's not how we talk about leak detection. How do we talk about leak detection when a system's low on refrigerant to a client? Yeah, we need to do a leak detection to find where the refrigerant is leaking, because it went somewhere, right? That's how we talk about leak detection. No more of the, well, you could do it. No, we don't tell a customer, hey, you could replace your capacitor. It's blown, you could replace it if you want, or you could just let it go and see what happens, right? Is that how we talk about that? No, we do not. That's an old school thing when refrigerant was cheap and when clients were easier to deal with. Nowadays, clients expect us to basically own their air conditioner largely. They don't want to have this problem happen again. It doesn't matter what conversation we have with them about things that are likely to cause another failure. If it fails again, they're calling back and they're blaming you. Leak detection is no longer something that we give them as an option. And not finding the leak is also not an option. Because if you didn't find a leak, there isn't a leak, right? That's the way you got to think about a leak. Either there is a leak and you're going to find it, or there is not a leak and you were wrong about it being low. Which one is it? And no, it isn't that the neighbor kid came and huffed some refrigerant, okay? That's the most ridiculous one I've heard. It's like, oh, I think someone's stealing refrigerant out of this unit. No, they're not. Stop it. Okay, stop. Now, it is possible that that cap didn't have a seal in it or something, and so when you uncovered it, you actually covered up the leak with your hose, but that's where you need to pay attention when you walk up to it. If you pull that cap off, ooh, it doesn't have a seal and I see a little bit of oil, get your soap bubbles out right now. Soap bubble that thing before to see, is it leaking? Or use your leak detector. And the only downside of putting soap bubbles in is then to get soap bubbles in it, and now you're going to put soap bubbles in the system, which isn't probably the best thing. But just get your head straight about these practices. Don't give yourself any excuses. I know why it happens, especially when it's busy. I get it. I feel that. But you got to just be like, nope, this is what we do. And that will solve so much of this. And on the back end, you'll be so glad because you won't get those calls. All right, final couple things. Drains, 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 drains. Drains are the number one reason why we have callbacks. They're the number one reasons why we have upset customers. They're the number one reasons for all of the pain and suffering and sorrow in our lives other than leaks. So don't just make sure that we have clean drains. Make sure that you have properly pitched drains. If a drain backs up multiple times, like, oh, I'm just going to clean it again. No, you got to slow down and be more thorough now. Like, what is going on specific to this application? And just take ownership of it. Don't be like, well, hey, I can't see it, so I don't know what's going on. Like, now we got to figure it out. We got to come up with a plan B. We got to do something. There is a product, especially if you get systems that get that. Do we get a lot of the elephant snot still? We're seeing that. And again, there's a difference between elephant snot that's like normal and elephant snot that's like every 2 months this thing is getting completely gummed up. And it's usually with all aluminum evaporator coils, okay? When we get that, there is a product, and we need to get it in stock, and I forget, this is really bad marketing, I don't know what it's called. Diversitech makes it, and it's basically a rope that you snake through the drain, and it has copper and silver embedded in that rope. And it's been tested and shown to eliminate the elephant snot problem, because elephant snot actually comes from outside. It comes from the ground, and it gets in the drain out of the ground. It's actually a bacteria, a special type of bacteria, comes in the drain, and so if you can prevent it from building up in that trap, then it doesn't back all the way up in. So even when you see it in the drain pan, that it's actually sourcing from outside and working its way in, not starting from inside and working its way out. At least that's mostly what the testing is showing on that. So That is a product that I want to have kind of be a common add-on when you've got clients who have problem drains. I want us to just start quoting it. And it's pretty easy. You just suck a little mouse through. So it's a little foam piece that gets a string, and then you use the string to pull the rope through. And then at the end, you just take it and kind of flip it over the drain and then just binder clip it so that way it doesn't come off. They don't advertise it this way, but the original inventor says that it's lifetime because it's not it's not like an antimicrobial fluid. It's actually using silver and copper within the rope, which I love because we know that that does work to deal with bacteria, because that's the reason why it's happening in the first place. In the past, when we had aluminum in our coils, those when we had copper in our coils, those copper oxides and those copper ions were making it down the drain and we're preventing that from building up. And the reason why it is happening now is because we have all aluminum, and so we no longer have that copper to help combat it. So copper was what prevented it before. Copper's the solution now. Make sense? In the meantime, if you don't have that, you can just take some little pieces of copper, like take some 3/8 copper, pound it flat, and lay it in the drain pan. And that does seem to help a little bit with that problem. Make sure that we have proper pitch, at least 1% or at least 1/8 inch for every foot of horizontal run. I say 1/4 inch. So that means every foot that it goes sideways, it needs to go 1/4 inch down. We can't have double trap, so we can't have it going up and down more than once, unless we have a vent, which this is showing a vent. We've got our clean out and then a vent. Obviously, for the types of systems we do, most often we don't do this. But if you ever do have a system that's going into a common drain, like in an apartment complex or multifamily, this is how it has to look. You have your clean out, then you have your trap, then you have your vent, and the vent stays open and the vent is taller than the drain pan. So in case it does back up, it backs up in the drain pan and trips the float, it doesn't start squirting water out of the vent and causing mass destruction and sadness and dogs and cats living together. And then just make sure you clean until it's clean. We talk about this all the time. We use shop vacs. Isn't necessarily the best way of cleaning a drain, but it is a way. What's better if you have a really bad drain line, drain pan, is to put a cleaner in and just let it sit. Now, we've talked a lot about drain solve, and I do not love how toxic that chemical is. I'm not a fan of that chemical. Sam and I have a little bit of a dispute about this, but the point is that if you are going to use drain solve, if you're going to have it in your truck, if you're ever going to use it, you have to treat it like what it is, which is a toxic chemical that will eat your eyeballs out of your face. Okay, so like I am not going to be the guy who ever downplays this and then is responsible for your blindness with your widow and poor children who can no longer be supported by you because you were stupid and didn't wear safety glasses and weren't careful with it. And it melted a hole in the bottom of your truck and destroyed everything. I'm a little passionate about this, okay? So just be really, really careful if you're going to use drain solve. Otherwise, use something like Refrigeration Technologies Viper Condenser Cleaner. You can even use the concentrate and just put a little of that in the drain line and the drain pan and let it sit. 10, 15 minutes, whatever, and then flush it out, especially once you've gotten the clog already cleared. So that way it's cleared, but maybe the drain still has some buildup in it. Once you use a cleaner, though, run a lot of water through it. Suck a lot of water through, because it's possible you may have some like hangers-on in there that can then clog it up again. So you just got to you got to make sure that you clean it until it's clean. Clean it until the drain pan looks clean. Clean it until the channels under the coil are clean. Just be really thorough about drain cleaning. Be really thorough about drain strapping. Be really thorough about making sure you have proper pitch. That make sense? Don't be dismissive about drains. Don't just pitch up the float switch because, oh, well, hey, it keeps tripping and I'm pretty sure if it's level, that's the problem, so we're going to just pitch it up a little bit. Like, if it doesn't seem right, it's not right. Be thorough about drains. Be creative about drains. Be thoughtful about drains. Think in your head, where's this drain routed that could be causing this problem? Is there any possible way it could be going up and down more than once? It's not the worst thing in the world, especially, majority of our installs are still garage. We got that platform. If you got to cut the drywall out and nice and square and then just put the piece of drywall back in and put a vent over it, that's not the worst thing in the world. Most clients, that's not going to bother them. And you're creating an access point in order to get in underneath that platform. If you got to do that in order to get down there and see what's going on, then that's what we got to do. Again, we got to talk to the client about it, make sure they're okay with it first. But it's not that big of a deal. Do you understand what I'm talking about with what I just said? You guys know what I'm talking about. You take a stamped grill, use some wall anchors. It's not hard to make it look right. Afterwards, it just looks like there's a vent there. There's not. It's just an access point with a piece of drywall behind it. Right? Make sense? All right. That's all I had. So you prevent these basic callbacks. If you have callbacks because of exotic, weird things that come up that none of us expected, that's life, right? That's life. It happens. But this sort of stuff is the sort of stuff we do not want to have callbacks over because it's so preventable. And that is how being a good technician is mostly just being a master of the obvious. It's just not letting obvious things go. All right, have a wonderful week. Thank you all.
Thanks for watching our video. If you enjoyed it and got something out of it, if you wouldn't mind hitting the thumbs up button to like the video, subscribe to the channel, and click the notifications bell to be notified when new videos come out. HVAC School is far more than a YouTube channel. You can find out more by going to hvacrschool.com, which is our website and hub for all of our content, including tech tips, videos, podcasts, and so much more. You can also subscribe to the podcast on any podcast app of your choosing. You can also join our Facebook group if you want to weigh in on the conversation yourself. Thanks again for watching.